Hello students, welcome back. Today in lecture number 6. In our previous lecture number 5, as we discussed, we were continuing the same topic, types of chemical reaction. Last time in previous lecture number 5, we have already discussed about combination reaction in detail. Today, our target is to discuss about decomposition reaction in detail. But before I start, as you all know, again my first suggestion, sit with book, pen, and whatever topics we discuss here needs to be noted down in your book one by one, and be alert, and as you are advised by me every time, you are sitting like a live classroom, understand? So today's topic we start. The topic is, I'm just writing it here. The topic today is 1.2.2. That is, the title of the topic is decomposition reaction. This is our topic today in our lecture number 6. We want to discuss today in detail about decomposition reaction. What is the meaning of decomposition reaction first? Name itself implies the meaning of the reaction. You can understand, and every student can guess. Decompose means to break. Let us try to understand, as we do in every types of chemical reaction. We will take one by one examples, and we will try to understand decomposition reaction. We will take one by one examples. Ultimately, the meaning somewhat gets clear in our mind. Decomposition meaning तो clear हो ही जाता है कि whenever any big molecule is broken down into smaller molecules, that is known as decomposition reaction. I just repeat and you should note down. Whenever any big molecule is broken down into smaller molecules, that is known as decomposition reaction. In textbook, they have given some activities, means experiment, to understand decomposition reaction. Just take an example. If we take one activity, that is activity 1.5, activity 1.5. They have in this particular activity tried to explain decomposition reaction. What they have done in this activity? So they have taken some vessel Understand, any vessel you take, in that you have to first take ferrous sulfate solution. I am just writing, it can be called iron sulfate also. You have to take ferrous sulfate in solid form. કોઈ પણ any vessel you take ferrous sulfate and note down the color of it. Actually, if you properly observe, the color of the ferrous sulfate is faint green. Understand? In fact, whenever we write the formula of ferrous sulfate, we usually write FeSO4. But ultimately, it is really FeSO4 7H2O, because ferrous sulfate contains 7 water molecules of crystallization. Its color, as it is said in activity, it is faint green color. It is faint green in color. Now what you have to do? You have to heat ferrous sulfate crystals with the help of either burner or gas flame. What happens? What you will observe when you heat ferrous sulfate crystal, which are faint green in color? So within short period of time, what you will observe? Faint green color of the ferrous sulfate crystals, understand, turns into little reddish brown. Not only that, at the same time, you will also feel some pungent smell also. Let me try to explain what actually happened. When ferrous sulfate solution is heated, it decomposes and forms actually ferric oxide plus sulfur dioxide and sulfur trioxide. Ferric oxide obviously in solid form, sulfur dioxide and sulfur trioxide are in gaseous form. When I said that faint green crystal of ferrous sulfate turns into reddish brown because of formation of ferric oxide. Actually, ferric oxide is reddish brown in color. At the same time, my dear student, you should remember that I spoke that you start feeling some burning sensation, means some pungent type of smell. That smell is of burning of sulfur. Sulfur present in ferrous sulfate crystal burns and produces sulfur dioxide and sulfur trioxide. Understood? So, this is one type of decomposition reaction. Understand, where ferrous sulfate crystals decomposed into ferric oxide, sulfur dioxide and sulfur trioxide. Pungent smell is burning of sulfur and reddish brown color is of ferric oxide. Understood? So, this is one type of definitely a decomposition reaction. Understood? But this particular decomposition reaction took place with the help of heat energy. Because we supplied heat energy here, ferrous sulfate crystal decomposed into ferric oxide, sulfur dioxide and sulfur trioxide. That's why we can call it thermal decomposition reaction. Okay, so my dear student, from this uh, equation definition might be clear that decomposition reaction where big molecule broken down into smaller molecule with the help of heat energy. So I may call it thermal decomposition reaction. Why it is thermal decomposition reaction? Because heat energy is supplied here. There are some other example also which are also an example of thermal decomposition reaction. Let me write one another. Just take an example, and here my dear student, one more point I should mention here. Actually, ferrous sulfate crystal consists of 7 molecules of water, and now when you heat it, it loses all 7 molecules of water, and understand this 7 molecules of water of crystallization are lost. Understood? And it turns into ferric oxide, sulfur dioxide and sulfur trioxide. One another example we can also mention, that is also an example of thermal decomposition reaction. Well-known example we have done also somewhere in balancing chemical equation. Calcium carbonate in solid form, when heated, I may write heat or I may put this particular symbol. This symbol also implies that heat is supplied to calcium carbonate. It will decompose into calcium oxide, that's in solid form, and carbon dioxide, that's in gaseous form. What happened here? By supplying heat energy, calcium carbonate decomposed into calcium oxide and carbon dioxide. Calcium oxide we discussed in our previous lecture, also known as either lime or quicklime. Understand? So this is also another example of decomposition reaction. I still want to mention one another example for your understanding. Understand? This is also an example of thermal decomposition reaction. Let me mention one. Lead nitrate, PbNO3 twice. Formula needs to be very clear, that you should be sure about. When lead nitrate, here I think in first reaction I forgot to balance, but you just have to write 2. That means equation is balanced. While you balance this equation, don't think about this, they are already lost. Lead nitrate solution. You take lead nitrate solution in some test tube, hold it with a pair of tongs and heat it. So within short period of time, when you heat it, what you observe, so suppose you have taken lead nitrate in some test tube like this, and you heat it, so within a short period of time, you will see brown fumes, dhumar, brown fumes coming out of the test tube. What does it suggest? It suggests that lead nitrate, by heating it, has decomposed into lead oxide plus nitrogen dioxide plus oxygen, gaseous form. Because nitrogen dioxide is Actually, you see that brown fumes, that is of nitrogen dioxide. So, my dear student, this is another example of thermal decomposition reaction. Three examples we have already discussed, and you must have noted down all three examples. All three examples I have written. This is activity actually 1.6, I think, in textbook. But be very sure, this is activity 1.6 they have given in textbook. But ultimately, all three examples I have written are of thermal decomposition reaction. So, decomposition reaction can take place with the help of heat energy. So, we call it thermal decomposition reaction. Understand? In exam, if you are asked define thermal decomposition reaction, how will you define? So you can say whenever a big molecule is broken down into smaller molecules with the help of heat energy, you can call it thermal decomposition reaction. Now, my dear students, let us try to understand some more thing. Is it possible that decomposition reaction take place with the help of light energy or electric energy also? Yes. Let me try to explain it. I think you must have noted down all three reactions. This is ferrous sulfate crystal, calcium carbonate and lead nitrate. All are example of thermal decomposition reaction. Let us move ahead and try to understand, is it possible that decomposition of molecules can take place with the help of electric energy and light energy also? In textbook they have given. Also in the form of activity. Let us try to understand it. Okay? Just take an example. We are trying to understand it. Decomposition reaction can also take place with the help of electric energy. With the help of electric energy. Well-known example, already somewhere you must have discussed and somewhere you must have read also, that whenever electric current is passed through water, it will decompose into hydrogen and oxygen. Let me just try to explain it with the help of activity. Take an example. Take some plastic mug like this. Plastic mug ले लो आप. Suppose this is plastic mug. They have already given in the form of activity in textbook. Plastic mug. Okay, looking good. Make two holes at the bottom and take two rubber stoppers and insert in two holes. These are rubber stoppers. Okay, plastic mug, two rubber stoppers we have inserted in the holes at the bottom. Now, take two carbon electrodes. Let me make it more proper. Two carbon electrodes, insert in rubber stopper. These are two carbon electrodes. Understand? Carbon electrodes we have taken, inserted there, and then they are connected with a 6-volt battery. We do not require more. 6-volt battery I have connected. This is positive, this is negative. This turns out to be anode and this turns out to be cathode. 6-volt battery already. Now, 6-volt battery. Then what you have to do? You have to pour the water in this and you have to cover. You have to pour water at least up to the level that the electrodes are immersed in it. Understand? Now, after doing this, what you have to do? Take two test tubes, fill them with water, and insert those test tubes on these carbon electrodes. Two test tubes consisting of water. Insert here. They are consisting of water. Before you start passing electric current, you need to add some drops of sulfuric acid so that water becomes good conductor of electricity. Ultimately, you all know that distilled water is a bad conductor of electricity. You need to add some few drops of acid to make it a good conductor of electricity. Okay, my dear student. Now, when you pass electric current within a short period of time, what you will observe? You will observe formation of bubbles here in this test tube and here also. Understand that is a formation of two gas when water is decomposed. This is water decomposed into hydrogen and oxygen gas. Obviously, oxygen gas collects at cathode and hydrogen gas collects at anode. More amount of hydrogen gas collect, understand, than oxygen gas, right? Because in formation of water also you all know that hydrogen and oxygen are in the weight proportion of અહીંયા 1 લખો 1:2. It means more hydrogen and less oxygen is produced. Understand? After, and you should remember, whenever the bubbles fill here, the water displaces downward. Understand? That is called downward displacement of water. Once total water, understand, comes down, and these two test tube get filled with this one get filled with oxygen and this get filled with hydrogen, and then you can test them whether this is oxygen gas or hydrogen gas. Just do one thing: take burning matchstick, bring it near the test tube containing oxygen. It will start burning with some good flame. Understand? Because oxygen is a combustible gas. Here, when you bring a burning matchstick near the test tube containing hydrogen, it start burning with popping sound. Understand? That suggests the presence of hydrogen gas. So here, water is decomposed into hydrogen and oxygen. I may write in the form of equation, directly a balanced equation. Water, when electric current is passed through water, electricity, it decomposes into hydrogen and oxygen gas. So this is an example of electric decomposition reaction. Means decomposition reaction can take place with the help of electricity also. Now, my dear student, you must have noted down each and everything here. Understood? Now, let me explain. Is it possible that decomposition reaction can take place with the help of light energy also? Definitely. Just take an example. In some, they have given in textbook in form of activity. Take silver chloride, AgCl. Silver chlorides, understand, in some china dish like this. Silver chloride applied. This is silver chloride, which is actually white in color. Understand? Now, allow light to fall on it. Allow light to fall on it. So, within short period of time, what you will observe, this white color silver chloride turns grayish. Why it happens? Because when light is incident on silver chloride, it decomposes into silver and chlorine. Understood? Right? To balance it, here 2, here 2. This is in solid form, this is in gaseous form. Silver chloride was initially, it was white, but because it decomposes and forms silver and chlorine, and silver, as you all know, grayish in color, understand, that's why after silver chloride is exposed to light, it turns grayish due to the formation of silver. So this is again an example of decomposition reaction with the help of light energy. One another I should also mention, my dear student, for you, so that you can make it more clear. Take an example, silver bromide, AgBr. When exposed to sunlight, what happens? It decomposes into silver and bromine. Understand? Again, to balance, as you all know, understood? Silver bromide broken into silver, decomposed into silver and bromine. Understand? So, my dear student, what happened here? By exposing silver bromide to sunlight, it decomposed into, just for balancing you should write, it decomposed into silver and bromine. So this is also another type of decomposition reaction. So decomposition reaction take place with the help of three forms of energy: heat energy, electric energy and light energy. Understand? Meaning is clear. What is the meaning of decomposition reaction? So when big molecules are decomposed into smaller molecules, which can take place either with the help of heat energy, electric energy or light energy. We have discussed three examples of decomposition reaction with the help of heat energy. One example, that is of decomposition of water with the help of electric energy, and two example where compounds are exposed to light and they decompose. This particular reaction is used in photography also. In black and white photography it is used. Okay, so decomposition reaction is clear. It can occur with the help of heat, light or electric energy. Hello students, let us continue in today's lecture another type of reaction. So far we have discussed about decomposition reaction and we also discussed about combination reaction. Now today, just now we continue in the same lecture topic 1.2.3 as per your textbook, that is, we are going to study now displacement reaction. This is our topic now. Displacement reaction. We want to study today this topic. Name itself gives lots of idea regarding displacement reaction. मीनिंग समझ में आता है कुछ? Displacement means something is to be displaced, substituted. That means somewhat the meaning gets clear by that way. Understand? For explaining to you displacement reaction, we will take some examples and try to understand what is actually the meaning of decomposition reaction and note down each and everything which I mention and whatever we discuss during our complete lecture. Understood? Let us try to understand displacement reaction. Actually, under this title, we are going to study two types of displacement reaction. single displacement reaction, which is sometimes called monodisplacement reaction, and we are also going to study double displacement reaction. In fact, what happens in single displacement reaction and what happens in double displacement reaction, let us try to understand it. My first target is to make you understand displacement reaction. We will understand it as we did in just now in decomposition reaction by some particular activities. Understand that has been described in your textbook also. So, one activity has been given in textbook, understood. Just take an example. If suppose you take two iron nails, suppose I have taken two iron nails, take two iron nails, they are given in form of activity, understand. Suppose I say this iron nail is A and it is as B, and the basic color of both is black, as you all know. I have taken two iron nails, just take two test tube also. Suppose two beaker or test tube, whatever. Suppose two beakers I have taken. I may say it C, I may say it D to just label it. In both, take copper sulfate solution. दोनों में you have to take copper sulfate solution. This is some apparatus arrangement and chemicals you required. You take two test tube, you take two beakers. In both the beakers C and D, you have taken copper sulfate solution, okay? And obviously, you have taken two iron nails also. Just to understand, we have labeled them as A and B. Now, the activity or experiment, this is some apparatus arrangement as I have drawn here. Note down the color of copper sulfate solution in both the test tube. That is your first target you have to do. So while you observe, as my dear student you all know, when you observe the color of the copper sulfate solution, it is obviously blue in color. So in both the test tube, color of the copper sulfate is blue, iron nail both are black in color. Now what we are doing in this activity, I am taking one iron nail A, and this iron nail I am going to immerse here in test tube or beaker C consisting of copper sulfate. This is suppose iron nail I have kept here. This iron nail is immersed here. Understood? After doing this, you have to wait for some time, around 15 to 20 minutes. And my dear student, after you wait for 15 to 20 minutes, you have to observe what happens in beaker C, which was initially consisting of copper sulfate solution, which was blue in color. Understand, copper sulfate is blue in color. It is also known as blue vitriol. That you should note it down, blue vitriol. Now this copper sulfate solution, understand, is blue in color, and I have taken iron Na and placed in this, and I waited and I observed for 15 to 20 minutes. And what happens after that? So after 15 to 20 minutes, I observe that the color of the solution now becomes faint green. It becomes faint green. Understand? An iron rod which was initially black in color now becomes reddish brown. Why this happens? Why the color of the solution turns faint green and why iron nail turns reddish brown? What reaction might have taken place? This question may arise in your mind if you are thinking कोई तो ये वस्तु कोई कुछ तो ऐसा हुआ है, something might have taken place, that's why the color of the solution has changed. Actually, what type of reaction might have taken place in test tube C? Let me explain you in the form of chemical reaction first. I have taken iron nail to mention it by symbol Fe. When I immersed iron nail in copper sulfate, that is CuSO4 liquid, iron nail immersed in copper sulfate, actually what might have happened that iron has displaced copper from copper sulfate and formed, means this iron displaces copper from copper sulfate and forms ferrous sulfate solution, and copper is displaced from here. Actually what happened? Copper sulfate, initially blue in color, converted into ferrous sulfate, which is actually faint in clear. So now here there is no copper sulfate. Now here is ferrous sulfate, which is actually faint green in color. And why the iron rod turned, initially it was black and turned reddish brown? Because of decomposition of this displaced copper on this iron rod. So iron turns reddish brown in color. So here, my dear student, can you understand from this activity? And if I ask you after the experiment gets over, what is the difference in the color of iron nail A and B? So B initially black, now also black, but A, understand, turns out to be reddish brown. What is the difference in color of solution in test tube C and D? So in D, that was kept undisturbed, remained blue, but here the solution turns already faint green. Understand? So this is one example of single displacement reaction, or you might say mono displacement reaction. Actually what happened? I am just trying to define single displacement reaction. Try to understand. If you compare iron and copper, which is more reactive? Iron, more reactive than copper. And always more reactive metal are always able to displace less reactive metal from their compounds. Understand? So actually what happened here? More reactive metal, iron, displaced less reactive metal, copper, from its compound, from its solution, copper sulfate, and formed iron sulfate, ferrous sulfate, as copper is displaced. So you can call it single displacement reaction. Not down. Just note it down. What happened? How will you define single displacement reaction? Just try to understand. When more reactive metal લખ્યું? When more reactive metal displaces less reactive metal from its solution and forms a new compound that is known as single displacement or mono displacement reaction. There are some other example also I can mention while I define single displacement reaction. Just take an example, zinc plus copper sulfate. Obviously zinc is more reactive than copper, so it will displace copper and form zinc sulfate, and copper is displaced. So this is also another example of single displacement reaction or mono displacement reaction. My dear student, in exam they may twist, ખાલી અહીંયા આટલો ચેન્જ કરે તો copper written here and here say ZnSO4, note down karo Cu plus ZnSO4, and they ask, is displacement reaction possible? No. Be very clear. Single displacement reaction take place only when more reactive metal displaces less reactive metal from its compound. Then it is known as single displacement reaction or mono displacement reaction. Clear થયું બરાબર? How will you define single displacement reaction or mono displacement reaction? You must have noted down. ફરીથી બોલું છું. Again I am speaking. When more reactive metal displaces less reactive metal from its compound and forms new compound, then such types of reactions are known as single displacement reaction or mono displacement reaction. Okay, so these two are example of single displacement reaction. Let us try to illustrate this topic more by taking some more examples. This is already we discussed single displacement reaction or mono displacement reaction. Okay, now let us try to understand some other example also. We are going to study now double displacement reaction. Single displacement reaction we already discussed. Let us try to understand now double displacement reaction. Double displacement reaction. Title itself gives you some meaning. Understand title itself, double displacement reaction. So here might the mind start thinking that there may be some topic of some double displacement might have been taking place. We will also try to understand it with the help of one activity. Understand? Just try to understand. If I take two test tubes, suppose I have taken one test tube, and in this test tube, try to understand it. I have taken in test tube A, suppose I have taken sodium sulfate solution. This test tube contains sodium sulfate solution. Okay. Now I take another test tube, that is test tube B. In test tube B, suppose I have taken barium chloride solution. Two test tubes I have taken. In test tube A, I have taken sodium sulfate solution. In test tube B, I have taken barium chloride solution. With the help of this activity, we are trying to understand double displacement reaction. Two test tube, one consisting of sodium sulfate solution, another test tube consisting of barium chloride solution. Now let me take another test tube. Let me mix both the solution in this sodium sulfate plus barium chloride. Both the solution are taken in this test tube and let me try to understand. After both the solution, sodium sulfate and barium chloride, are taken in this third test tube C, wait for at least 15 to 20 minutes. Just wait it and be watchful and observe what happens. After you wait for 20 to 30 minutes or 15 to 20 minutes, what you will observe here, my dear student, you will see one transparent liquid formed here. Not only that, transparent liquid forms, but at the same time you will also see tiny insoluble white particles here. Understand, two products, tiny insoluble white particles here and transparent liquid solution. Actually, after we observe this, the question may arise in our mind that what type of reaction might have taken place here, why the transparent liquid is formed, and what are those white tiny particles. Understand, let us try to understand actually what might have taken place. We have taken sodium sulfate, Na2SO4, plus we have mixed it with barium chloride. Obviously, when you mix both the solution, you also have to stir them with the help of glass rod. A glass rod, if you keep it and just try to stir the mixture of sodium sulfate and barium chloride for 15 to 20 minutes and be watchful and observe actually what happens. When these two solutions are mixed and stirred, actually exchange of ion take place and two new compounds are formed, are actually NaCl and plus barium sulfate, BaSO4. Let us first try to balance it. I just placed 2 here because 2 chlorine atoms, 2 sodium. I think the equation is already balanced. Actually, the transparent liquid which is formed here is of sodium chloride, and the white tiny precipitates, અહીંયા નાના white tiny particles which you see can also be called precipitates. So your tiny white small precipitates are formed, and those precipitates are of actually barium sulfate in solid form, and this is aqueous form. So my dear student, which reaction might have taken place between these two compounds? Exchange of ion took place. Actually, sodium combined with chlorine, barium combined with sulfate ion and formed tiny white precipitates of barium sulfate, and sodium chloride solution is formed. Because here, when two compounds react with each other, exchange of ions took place. Understand? Because exchange of ion took place, here this and here this. Because the exchange of ion took place between two compounds, and as a result, two new compounds are formed. So that's why this is known as double displacement reaction. Understood? So make it more clear. What is the meaning of double displacement reaction? So when solution of two compounds are mixed, understand, exchange of ion take place. Understood? As a result, two new compounds are formed. That's why we can call it double displacement reaction. Understood? So, is it clear? Double displacement reaction. Okay, my dear student, how will you define double displacement reaction? When solution of two compounds are mixed, understand, exchange of ion take place between them, and two new compounds get formed. Understand, this is known as double displacement reaction. Understood? If in exam they ask you what is the difference between single displacement and double displacement reaction, which I am going to dictate in today's homework. So in single displacement reaction, how will you define? So when more reactive metal, you must have noted down, displaced less reactive metal from its compound and forms new compound, that is known as single displacement reaction. And then you can give example of that, iron and copper sulfate or zinc and copper sulfate. Double displacement reaction, when solution of two compounds are mixed, exchange of ion took place and two new compounds are formed, that is known as double displacement reaction. Understood? And then you can write this example particularly as a second point. So my dear student, so in displacement reaction there are two type of displacement reaction: single displacement reaction and double displacement reaction. So before we end our today's lecture, my dear student, two topics which we have discussed, and then just now I will give the homework for this lecture. We discussed about today decomposition reaction with the help of heat, electric and light energy, and we discussed about double displacement reaction. Understand, that is single displacement reaction, and we also discussed about double displacement reaction also. Okay, I think before I deliver homework to you, my dear student, please note down each and every question which I am speaking. As I told you in my previous lecture 5, I will speak the question. First you make the title, homework for lecture number 6. Make the title, I am speaking question number 1. First question. Define, okay, decomposition reaction first. Second, what is thermal decomposition reaction? Explain. Note it down. What is thermal decomposition reaction? Explain. Third, what is electric decomposition reaction? Explain. Here you can explain that activity of decomposition of water with the help of electric energy. Third question, should I speak again? What is electric decomposition reaction? Next, explain or what is photochemical decomposition reaction, where I have explained you decomposition. You can see in your textbook decomposition of silver chloride and silver bromide, as you know. That is question number 4. Should I repeat it? What is the question? What is photochemical decomposition reaction? Okay. Question number 5. Displacement reaction. Define displacement reaction. Okay, note it down. Define displacement reaction. Question number 5. Question number 6. What is single displacement or mono displacement reaction? Explain. Should I speak again? What is single or mono displacement reaction? Explain. We have already explained. You can note it down from that. Next question. Question number 7. What is double displacement reaction? Explain. Should I speak again? What is double displacement reaction? Explain. Your question number 8. Here precipitates are formed, so same reaction can also be asked in this way. Lakho, question number 8. What is precipitation reaction? Precipitation. What is precipitation reaction? Explain. In that you have to explain this double displacement reaction itself. Your question number 8. Should I speak again? What is precipitation reaction? Explain. Next, question number 9. Whatever number, note down karta jao. Question number 9. Differentiate between single displacement and double displacement reaction. Should I repeat the question again? Differentiate between single displacement reaction and double displacement reaction. Understood, my dear student? This is homework for today's lecture. First 4 previous lecture, understand? And in today's lecture, lecture number 6, the homework has been dictated. You all have already noted down each and every question. Material PDF are available to you, or even without opening PDF also, if you have concentrated in my lecture, it is sufficient for you to understand and write in your own word also. Okay, So complete your homework properly in neat and clean writing. Understand, काम में कुछ भी जो भी whatever work is given to you, it is like a work given in our live classroom. So my student, feel comfortable, try to understand the topic, complete today's homework neatly and submit to the associate teacher so that they can verify your answers properly. I expect my every student will be sincere enough, understand, for whatever homework it is given to you, please write on foolscape page in neat and clean writing point wise so that we feel it comfortable to verify your homework. Understand, and if you have any doubt, you can contact associate or Bharat sir. Phone numbers are with you. Thank you very much from Bharat sir.